So we've got a lurking variable is related to both the explanatory and the response variable. So this one they say ice cream sales and crime rates have a high correlation. So in days where there's a lot of ice cream sales, there's also a pretty high crime rate. And then they asked, does that mean that local governments should shut down all ice cream shops because selling ice cream causes a high crime rate? So the answer to that is obviously going to be no. In this case, it might not be obvious to see, but the lurking variable in that one is actually just going to be temperature. So as temperature increases, people are more likely to buy ice cream, and it's also been shown that as temperature increases, crime rate also increases. So that's going to be the lurking variable there that has an effect on both of those different things. So that's what a lurking variable does. And we've got another example of bone mineral density. Let's see, this one's in here. Yeah, there we go. Okay. All right, so we're looking at women, so we've got 15 women altogether. So we've got 15 women, and they're looking to see if cola consumption is associated with lower bone mineral density in women. So again, this is going to be something that's going to be an observational study. They ask them how many drinks do you have per week, and then they measure their bone mineral density. They don't randomly assign, you drink this many, you drink this many, you drink this many. So it's going to be an observational study because the researcher is not putting them into their categories randomly. So we can't say that, even if there is a correlation, we can't say that there's a causation. So with these ones, let's see if I can get these all on the same page. Yeah. So they're asking us to find the, well, here's their scatter diagram they give us for that. They want us to find the correlation coefficient for this one. So this one, again, we have to put it into our L1 and our L2. There's that edit. There's 15 of them all together. Some of them repeat. Most of them repeat. Oops. So once you've got everything into your L1 and your L2, you go to Stat, Calc, and then again, since we're in Chapter 4, we're going to scroll down to number 4, linear regression. I just need to hit enter. You might have to make sure your X's are an L1, your Y's are an L2. And then at the bottom, you've got your R. Notice that R is negative. Sometimes it's easy to miss that one. But we do have a negative relationship between the two, because if you look at your scatter plot, the lines are kind of pointing down and to the right, so it should be a negative relationship. That does look fairly linear. So in this case, we've got a negative 0.806. So I'll say my correlation coefficient is negative 0.806. And again, it's going to be in between -1 and +1. Some sort of a decimal. All right, and so since we've got 15 of them, we have to look up the critical value. So if we look up here for our critical value, oh, mine's missing. It's in table 2 in the back. Like I said, when you do the homework, it'll include it for you. You can just click on it. Here we go. Table 2 in the back of the book. On a test, I'll have that table for you as well, and I'll be sure to include all of the numbers that you need. This one's missing a 1. So we've got n equals 15. If I look that up, I get 0.514. Look it up from the chart on your homework. You'll just have to click on the button and pull up the table. On a test, I'll have it included for you. Okay. And so now with this one, it's a little tricky because some people miss it when they've got a negative correlation coefficient, and they say, well, this negative 806 is technically smaller than this on the number line, which is true, it is. With this 0.514, that's a cutoff point for both the positives and the negatives. So this 0.806 is actually going to be pretty close to a -1. So we still want to say that this one's going to be linear because if you just look at the absolute value part of it, the absolute value is going to be larger than this 0.514. So if you look at this one, in this case, if R is negative, then our R equals negative 0.806. We want to actually take the absolute value of R, which is just 0.806. And that's the one that we want to compare with our critical value. So this value is larger than 0.514. So in that case, we have a linear relationship. And specifically, it's going to be negative because our R is negative. So we do have a negative linear relationship. But when we're testing it against the critical value, we always just want to look at the absolute value. That way it doesn't throw it off if it's negative. Otherwise, every time we find something negative, it's going to be not linear. So you want to be sure with those ones to find the absolute value first before you compare the two. So it says we conclude a negative linear relation exists between the number of colas consumed and bone mineral density. It says, can the authors conclude that an increase in the number of colas consumed causes a decrease in bone mineral density? Then down here, here's our answer. The researchers cannot conclude that increased cola consumption causes a decrease in bone mineral density because it wasn't a designed randomized experiment. It was an observational study. So these groups, the people kind of already had put themselves into it. The groups weren't assigned randomly by the researchers. So even though there is a really big high correlation, we say that there is a linear correlation between the two. We can't say that drinking a lot of pop causes your bone mineral density to go down. In order to say that, we would have to assign people, a certain number of pops to drink per week, and then we'd have to wait quite a bit because it's actually something that happens over time. So that would take a really long time. We have to start them young too, because one of the lurking variables that could be in here is age. So, as women age, their bone mineral density goes down. So maybe women who are older tend to drink more pop. So maybe that's an option. We've also got something like calcium consumed. So if they're drinking more pop, they're not drinking as much milk. So maybe then their bone density goes down. So maybe that's a lurking variable. It's another one. Forget they have 3 listed. I'm not good with coming up with lurking variables all on my own, so I'm not going to give you one on a test because it's hard to come up with those, unless you're really knowledgeable in that field, which I'm really not with bone mineral density. On the homework, I think they have some questions, but it's a multiple choice and you can select which one you think makes sense. So in this case, they might give you a few different options and you pick the one that you think would make the most sense. Oh, that's another one. That's good. Body mass index. Body mass index. So if they're drinking a lot of pop, they're consuming more calories, so maybe their BMI goes up a little bit, and so then maybe their bone mineral density goes down. So not saying these things are lurking variables, but they're just potential lurking variables that could have an effect on both of these things rather than one causing the other.